Good morning, dear students. I am Miss NAVEDA SHAIKH from Brahan Mumbai Mahanagar Palika MCGM virtual class. I welcome all my dear students to another and interesting session. In today's session, we'll be learning something new and interesting from a science textbook. So let's get started. Good morning, dear students. I am Miss NAVEDA SHAIKH from MCGM virtual class. Welcomes all my dear students to another and interesting session. In today's session, we'll be learning with the remaining part of the chapter, that is current electricity. Now we have learned few things already in this chapter. We have learned what is the meaning of electrical potential. We have learned potential difference. We have learned what are free electrons and how current flows. Okay, so with this we move on to the next part. Let's get started. Our ancestors relied on fire for light, warmth and cooking. Today, at the flick of a switch, turn off a knob or the push of a button, we have instant power. This is possible because of the electric current. It is one of the important discoveries that helped us revolutionize the way we live. From the time we wake up till the time we sleep in the night, our life is dependent on electricity. From the television set that you watch to the toaster that you use to toast bread, all run on electric current. Besides playing a major part at home, electricity also plays an important role in industries, transportation and communication. So it is important for us to understand about electricity, electric current and the terms related to it. So let's move ahead. So last week we have learned about the flow of electrons, and this brings us to a very interesting part of this chapter that explains us how these electrons are moving. We learned that electrons can move easily in a conductor, in a wire. So electrons are minute particles that exist within the molecular structure of a substance. Sometimes these electrons are tightly held and the other times they are loosely held. As you can see in the first picture, they are easily moving. When electrons are loosely held by the nucleus, they are able to travel freely within the limits of the body. So here they are easily freely moving around in the body. Electrons are negatively charged particles, hence when they move, a number of charges move and we call this movement of electron as electric current. So here you can see how these electrons are moving. This generates electric current. This flow of electron is called as electric current. It should be noted that the number of electrons that are able to move govern this ability of the particular substances to conduct electricity. Now there are some materials which allow current to move better than the others. So let's have a look at what is current, electric current in detail in the next coming slide. See, electric charges. First thing to understand about electric charge is electric charges are made up of positive charge, that is protons, and negative charge, that are electrons. When these charges flow in a circuit, a current is produced. Here you see how the electrons are moving and how the protons are situated in the center in the nucleus. Now when there is a movement in this, there is current produced. So it is important. Here you can see how current is produced because of the flow of the electrons that are there. Let us understand about what is an electric current. Let us understand what is an electric current. An electric current can be easily understood with this diagram. There is a battery and this battery is connected to a bulb through connecting wire. This connecting wire helps the electrons to flow. So when these electrons flow, there is a current which flows along with it. So an electric current is the flow of electrons through a conductor. Meaning जो electrons है जब वो flow करते हैं conductor के through, that is called as electric current. Quantitatively, current I, that is I is the symbol for current, is defined as the charge passing through a conductor in unit time. How much charge passes in unit time? That tells us the amount of current. If charge Q is flowing through cross section of a conductor in time t, then the current is given as I is equal to Q upon T, where I is the current, Q is the charge and T is the time taken. Alright, so with this I hope electric current is clear to you all. So how does electrons flow? The battery in a circuit gives energy to the electrons. जो battery connected है ना, वो energy देती है electrons को and it pushes them around a circuit. From the negative terminal of the cell round the circuit and back to the positive terminal of the cell. So here in this picture, if you look at the battery that is situated on the left hand side, which is green in color that you see, it has a plus and a minus side. So how the electrons are flowing from the negative end towards the positive end. And if you just look at the arrow for the current, it is in the opposite direction. ठीक है, जो ऊपर आप लोगों को रेड कलर का arrow दिखाई दे रहा है, that indicates the current which is from the positive towards the negative end. So with this, I hope it is clear how the electrons flow. इलेक्ट्रॉन्स फ्लो होने के लिए एनर्जी की जरूरत है जो वो बैटरी सप्लाई करती है. जब बैटरीज को कनेक्ट किया जाता है, बैटरीज चार्ज सप्लाई करती है टू द इलेक्ट्रॉन्स एंड दीज इलेक्ट्रॉन्स आर पुश्ड and they move around in the circuit. This is clear? Now there is an important point to remember. Even though electrons move from negative end to positive end, conventionally the direction of current flow is taken to be opposite of the direction of flow of electrons, that is from the positive end to the negative end of the cell. Now here in this picture it is very clearly shown to you all. If you see on the right hand side I have a plus sign, okay, that is the positive end, and on the left hand side I have a minus sign which indicates the negative end. When you see the electrons flow from negative to the positive side. ठीक है, नेगेटिव एंड से पॉजिटिव एंड की तरफ इलेक्ट्रॉन्स फ्लो हो रहे हैं, बट the current which is applied is normally it is from the positive end to the negative end. मतलब ये दोनों opposite है एक दूसरे के. जो direction है flow का, it is always opposite. Electrons का flow है from negative to positive and current का flow है from positive to negative. Now how to measure current? The SI unit of electric current is ampere. The unit of charge in SI unit is coulomb, that is denoted by C. Smaller currents are measured in milliamperes, that is MA. M should be small and A is capital, remember that. So 1 ampere is equal to 1000 milliampere and 1 milliampere is equal to 0.001 amperes. Different electrical components and appliances require different size of current to turn them on. Now if you see a clock hanging in your house, the amount of current that clock requires is very different from the current required by a refrigerator. ठीक है, so it depends, हर electrical component को अलग size का current लगता है. Very small values of current are expressed in the following units. 1 milliampere is equal to 10 raised to minus 3 ampere and 1 milliampere is equal to 1 microampere is equal to 10 raised to 6 amperes. So what is an ampere? An ampere is the 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. As we know, the unit for charge is coulomb and the unit for second is S and the unit for ampere is capital A. So if I just make a simple formula using this statement, it would be 1A is equal to 1C upon 1S. As it says, 1 ampere current is said to flow in a conductor. अगर एक करंट फ्लो हो रहा है, एक 1 एम्पियर करंट अगर फ्लो हो रहा है कंडक्टर से, सो इफ 1 कूलम चार्ज फ्लोज थ्रू इट, इट विल एट एवरी सिंगल सेकेंड. सो 1s हम लोग लिखेंगे फॉर सेकेंड, कूलम के लिए 1c एंड फॉर एम्पियर 1a. So remember, this ampere is in capital, C is also capital, but S is a small letter. So that way you have to remember while writing the formula. This man, that is André Marie Ampere, he was the French mathematician and scientist. Ampere conducted a number of experiments on electricity. Today we can measure the current flowing in a conductor only because of his extraordinary work. The unit of current is called ampere in recognition of his great work. So जो ampere अभी हम लोग ने पढ़े थे वो इनके नाम पर दिया गया था. Now the instrument used to measure current is called an ammeter. An ammeter is an instrument used for measuring electric current and it looks like this. उसके shape vary करते हैं अलग अलग use के हिसाब से, but basically it looks like this. This brings us to a very interesting part of the chapter, that is the Ohm's law. Now if you study Ohm's law today, you will remember it throughout your life. If you just read one statement, it comes automatically to your mind. The entire statement will flow into your. Now it was given in 1828. George Simon Ohm, a German physicist, derived a relationship between electric current and potential difference. This relationship is known as Ohm's law. You have learned about electric current now. You learned about potential difference in the last class. If you are confused, just go through the video and you will understand what is potential difference. Certain formulas in physics are so prevalent that they become popular knowledge and you end up memorizing them without even trying. So as I told you that today if you learn Ohm's law, it will remain in your head throughout your life. So let's see what exactly is Ohm's law. Ohm's law is the relationship between the current flowing through a wire and the potential difference across its end. Means any wire which is connected, ठीक है, उसके दो ends होते हैं, तो उसके बीच का जो potential difference है उसके बीच में relation और जो current उसके अंदर flow हो रहा है, ये दोनों का relationship के बारे में बात होगी in this law. So this law states if the physical state of a conductor remains constant. Now what is the meaning of physical state? Physical state of a conductor means its length, the area of cross section, the temperature and the material it is made up of. अगर एक वायर टंगस्टन का बना है या फिर अगर एक कॉपर वायर है, ठीक है, वो वैसे ही अगर रहेगा, उसको हम लोग ना उसका शेप्स चेंज करेंगे, ना उसकी लेंथ चेंज करेंगे, ना उसका टेम्परेचर वेरी होगा. So that is called as the physical state. अगर वो वैसा ही रहेगा, उसका physical state वैसा ही रहेगा, then the current flowing through it is directly proportional to the potential difference between its two ends. See, now it states that the current flowing, जो अभी वायर है तो उसमें से current तो flow हो रहा है, ठीक है. Here you can see in this picture also the current is flowing through the conductor, through its, and it is directly proportional. Means अगर एक बढ़ेगा तो दूसरा भी बढ़ेगा, ठीक है, directly proportional to the potential difference between its two end. उसके जो दो end में potential difference create हुआ है, ये दो के बीच का relation है, ठीक है. They both are directly proportional to each other, ठीक है. Let us see the formula for this and you will, the concept will be much more clear. Before I move on to the formula, just one more time we'll read the Ohm's law. If the physical state of a conductor remains constant, the current flowing through it is directly proportional to the potential difference between its two ends. So, physical state of a conductor समझ में आ गया क्या कहते, किसे कहते हैं. Physical state means अगर एक copper wire है 2 सेंटीमीटर का है तो वो 2 सेंटीमीटर ही रहना चाहिए और वो चेंज नहीं होना चाहिए, ना उसका टेम्परेचर बदलना चाहिए, ना उसका साइज, ना उसका क्रॉस सेक्शन एरिया. It should be as it is. If it is as it is, then the current flowing through it and is directly proportional to the potential difference between its two ends. So this brings us to the derivation of the formula, that is current is directly proportional to the potential difference. So I is equal to kV, where K is the constant of proportionality. Now this K, if you remember, you have learnt in variation and I hope you remember why are we using this K here. So I into 1 upon K is equal to V. Now why this just happened? We got the K onto the left hand side. So it became the reciprocal of it. So 1 upon K is equal to R, which is the resistance of the conductor. I into R is equal to V. Hence V is equal to IR, or R is equal to V upon I. This is known as the Ohm's law. V is equal to I into R is the actual formula that you keep in mind for Ohm's law. You can move it here and there in order to get the answers for the sums if you need to solve. So we can obtain the SI unit of resistance from the above formula also. The potential difference and the current are measured in volts and ampere respectively. Respectively जब भी word use होता है, it means that पोटेंशियल डिफरेंस का यूनिट है वोल्ट्स और करंट का है एम्पियर. सो इट गोज लाइक दैट. द यूनिट ऑफ रेजिस्टेंस इज कॉल्ड ohms and it is indicated by the symbol ohm. Now ohm is indicated by the symbol. You have to remember this. All right. Let us understand our next important topic in this chapter. What is an electric circuit? Electric circuit, basically here you can see this image. Electric circuits are made up of electrical components like the connecting wires. You need a battery, you need a light bulb to complete a circuit. These components must be joined together without any gap in between to form a closed circuit. Example, here in this picture you can see everything is connected to each other. The light bulbs are connected to the connecting wires, and the connecting wires का जो second end है, it is connected to the electric cell. So everything has to be connected to each other in order for the current to flow through it. Electric circuits, it is here in this picture, it is seen that both the images have some or the other thing missing. In the first picture, you do not have the connecting wire, so the current will not flow. In the other picture, if you notice, the battery is missing. You have the connecting wires, you have the bulb, but the battery is missing. So no source of electrical energy is there. So both the circuits in the diagram are incomplete. Hence they are known as open circuit. So incomplete circuits are called as open circuit. An electric current flows only when there is a source of electrical energy and a closed circuit. Means you need a battery, proper battery, and it needs to be closed circuit. Means batteries should be connected, the connecting wire should connect the battery also and the light bulb as well. The next important components that are there in an electrical circuit are the switch. A switch is used to open or close a circuit. Now in your houses also you make uses of switches to put it on and put it off. When you put it on, what happens is the circuit is complete and you can see the fan moving, the lights are on, the television is on, right? So main switch used in buildings that you see here in this picture, and these are a few examples of switches used on circuit boards. This is how the switches look when it is made on the circuit board. Now how to draw a circuit diagram? Now we cannot draw an electric cell or a battery or a switch in such perfection while drawing a circuit diagram. So we make use of simple symbols like that of an electric cell. You can see that I have a list of the components and their symbols given to you on screen, and it is very simple to draw this. Okay, you can easily draw a electric cell with the help of the symbol that is given to you, and if you want to draw a battery, the symbol is also very simple over there. When you need to draw a switch, it is just drawn with such simple lines, and if you want to draw a lamp, you just make a circle and mark an X. Same way it goes for connecting wires as well. So symbols are used to represent the various electrical components in a circuit. So instead of drawing such huge 3D diagrams of electrical bat cells or the batteries or the switches or the bulbs, we just need to make use of the symbols that are there. So this way we can make use of the symbols in order to draw a circuit diagram for open and closed circuit. The first image shows us about the open circuit where the key is not closed, the key is open and the current will not flow. As I told you, कि स्विच इज वेरी इंपॉर्टेंट. अगर स्विच क्लोज होगा तो ही करंट फ्लो होगा. अगर स्विच ओपन रहेगा तो द करंट विल नॉट फ्लो. बिकॉज इसके हम लोग ने सबसे स्टार्टिंग में क्या पढ़े थे कि करंट फ्लो होने के लिए एवरीथिंग शुड बी कनेक्टेड टू ईच अदर. अगर बीच में से कोई भी चीज हट जाती है तो वो करंट फ्लो नहीं होगा. So if in this case there is an open current, so bulb does not light up when the switch is open. Whereas in the other case, the bulb will light up when the switch is closed. तो जैसे ही हम लोग इसे close कर देंगे switch को, it will glow. So with this, I hope the simple concept of circuit diagram is clear. There are few more symbols given in your textbook. You could go through them as well. So with this, I end my session here. I hope the concept of electric current, electric circuit and Ohm's law is clear to you all. In the next coming period, we learn something new and interesting. Till then, thank you.
If you liked our video, please subscribe to our channel and do not forget to hit the like button.
Hope this session was quite useful to you. In the next coming period, we'll learn something new and interesting. Till then, thank you.